Greetings, everybody. My name is Cinque. I'm a third year master's student studying engineering management at the University of Tennessee at Chattanooga. And today I will be presenting my final presentation about process creation for the UTC's Automotive Engineering course. Without further ado, let's get right on to it. There we go. So a look at our table of contents. We'll be discussing the project overview, initial configuration and requirements, the time study results, since I was a part of the time study group, process improvements, and lastly, recommendations. So bear with me because this is kind of it's gonna go since we're on a time crunch. So for our project overview, a little bit of background. We're taking this course at the Volkswagen Leading Academy Center. And for the final project, we had a hangar and cars attached to said hangar that were moving, kind of simulating the assembly line. And the hangar is going to move the length of a pitch, which is 6 meters. So the students' role, our role in this project, is to kind of act like industrial engineers in that we're going to observe the process, document it, while the Volkswagen team member is doing multiple iterations. And as we're documenting, we're recommending changes to help optimize the process in order to achieve our target key performance indicators. So that's a little bit of background. Now we'll talk about the initial configuration and the requirements. So initially, as you can see, we have two parts racks, one parts table, two cars, and more info about this graphic. The work at the car is going to be done in green, and the work away from the car is going to be done in red. And the transition slash waiting is going to be indicated by dotted lines, while working is going to be indicated by solid lines. So keep in mind, this car is moving. These cars are moving on a hanger, so they're moving. So notice off back, we have a lot of back and forth, back and forth, back and forth. So that's how it was initially. Also, we have a look at some of the process steps for our first trial on the left, second trial on the right with times included. Then we also have a first spaghetti diagram at the top left. You see how it's kind of all over zigzags, zigzags. And then the second spaghetti diagram on the left, a little bit more controlled, but that is initially how we ran our initial setup. And then you see pictured is the two parts racks and the one table and our pitch. So the requirements for this project process, I'm sorry, is we want to have good ergonomics, want to make sure the worker is comfortable. We also have a tach requirement of 90 seconds. Value added, we want that to be 60%, non-value added 30%, and utilization, we want that to be at 92%. So now that we've discussed our initial setup and our requirements, we'll now discuss the time study results. So we have all the parts listed, all the 10 parts, all the 10 steps to the process listed, as well as our control times and then our times for each trial. Notice all trials are displayed in seconds. So we also have the totals and the averages, but the big takeaway from this time study is that starting from the control, the more trials we ran, the less our total cycle time was, which is good. So we also indicated some non-value added versus value added times. This graphic you can see at the top, 2 minutes and 11 seconds was our control time, and then followed by each trial we can notice that the value added time is increasing and the non-value added time is decreasing, which is good. That's what we want in this case. That's how we know that the changes that we're recommending are good changes. And more moving along to process improvements. We started off with the different non-types of waste, but notice since we're observing this Volkswagen worker, they have been doing this for a while. So it's tough to identify all types of waste. But the ones that we did observe, like movement, ergonomic working, weighting, and skills, we added some countermeasures like providing the worker with a logical workflow, like working from front to back, giving him aprons, allowing him, the worker, to start with the parts on his hand, reorganizing the parts. All of those countermeasures we developed and implemented based on the waste we initially observed. So pictured here is a more optimized, it's our optimized final setup. We have one part rack and two small tables. That way, the worker is always within optimum reach, and we're reducing the extra waste like movement, weighting, and all that good stuff. So visually, our optimized process layout, we saw earlier there was a lot of back and forth. There's not as much as that in our optimized layout. We also, as mentioned previously, only working with two parts racks and one table. Two tables, I'm sorry, two tables and one parts rack. So that shows that now we're in optimum working process, and we can also discuss our ergonomics and our cycle time. So notice for each part of the process, starting with the first trial, everything was poor, moderate ergonomics. Like we noticed the worker turning a lot of extra movements, reaching. So by the fourth one, we were able to provide recommendations to get all of those steps in the process to be good ergonomics. You could also see in the second table, we have value added time, non-value added utilization, and total cycle time. Now, and this is per trial. This is per trial. So the key takeaway from this is utilization percentage is calculated by takt time, which is 90 seconds, divided by our cycle time, and of course multiplied by 100 for the percent. We can see that our target utilization is 92%, while the first two trials we kind of fell short. The basically the process can't keep up because we're overutilization. But even though we never reached our target of 92, the worker was meeting TAC capability on the third trial, and he was a little bit below utilization, but the total cycle time improves, which is good. So moving on to our recommendations, I have recommendations for each student group as well as general recommendations. So for the time study group, I would just recommend somebody to be there to count the steps and communicate those step findings to the layout team so we can have a more defined spaghetti diagram. For the line balancing group, I would recommend just constantly share those order of operations with everyone. That way we're all on one accord, and try to aim for consecutive trials where the worker is meeting TAC capability when he's at our target utilization, because that's going to benefit the process in the long run. And lastly, for the layout team, I would just say more clearly defined spaghetti diagrams. We only had two, and those didn't have steps, so more spaghetti diagrams, and also a whiteboard area. That way, as changes are being made to the layout, the other team members can see. Moving on to the general recommendations, I would say every group should have a representative. That way, communication is seamless and documentation is accurate to help essentially make the group operate at the most efficient way possible. And also, we could set up base of operations or headquarters. That way, as the trials are going, we'll have set stations for everybody to wait at. That way, if we're documenting, nobody's interfering with anybody's documentation, nobody interfering with the workers, etc., etc. Now, I know this is kind of quick, but I really appreciate y'all for sitting through this presentation. If y'all have any questions, please contact me at the email below, or you can contact the UTC College of Engineering. The link is below. This is my works cited page, and I thoroughly appreciate y'all for watching this presentation. Y'all have a good day.